Standard 8246 is going to talk about equations and inequalities using absolute value and how we figure out the solutions and graph them on number lines. Question 1, Part A, write an absolute value inequality that represents all values more than 2. So more than 2, and it is 2 units away from 5. So we need to go ahead and solve this. Here's the units away from 5. That's that absolute value. We need to be 2 units away, more than 2 units. So this has to be more than 2 units away from 5. Now remember, to solve these absolute values, absolute value is isolated already. This is the only thing on that side is your absolute value. So you split it up into 2 cases, a positive case, and then you have the negative case. So we use a set of parentheses, getting rid of the absolute value so we can solve. First things first, on this one we would add 5 to both sides, and we have x is greater than 7 is one possible option. Next equation, we needed to get rid of the negative sign. The negative sign is distributed in what is inside that parentheses, so it's basically multiplying. So I'm going to go ahead and divide by -1 to get rid of the negative sign. When you divide by -1, your inequality will flip. You now have x minus 5 is less than -2. To get x alone, you would add 5 to both sides. And we have x is less than 3. So now we have the two solved. Down in B it says graph the solution from part A on a number line. Here's my number line. It's going to cover values for 7 and 3. We check out that first inequality where it says x is greater than 7. We'd have an open circle on 7. The values that would work for x are the values to the right of 7. Those are the values greater. Next we have x is less than 3. Open circle on 3. What are the values for x? Those are the ones that are less than 3. There it is, graphed. Example 2, you're given an equation. What is the solution to the equation? First things first, check it out. Absolute value is isolated, so make 2 cases for it. And here's our 2 cases. There's our positive case, and there's our negative case. So go ahead and solve for x in both these problems. Right here we're going to go ahead and subtract by 2 on both sides, and we have x equals 8. The next one, we're going to go ahead and get rid of that negative sign. That negative sign is being distributed, so I'm going to go ahead and divide this side by -1. Divide by -1. We have x plus 2 equals -10. Get x alone. In order to get x alone, I'm going to subtract by 2. And we have x equals -12. So the 2 options with absolute value, which you normally have 2 options covering both cases, 8 and -12, which would be option D. Example 3, it's kind of a little special one here. What is the solution to the equation given? Well, absolute value is isolated. There's nothing happening on that side. When you have the absolute value isolated, we know that you cannot have a negative outcome using absolute value. For D would be our answer then. There are no solutions. You cannot wind up with a negative outcome with absolute value. 8 says which inequality has the solution represented by the given graph. There's the graph there. We need to go ahead and solve, and we just need to pick one of these out and play with it and figure out which one would give us the graph given. I'm going to go ahead and select D right away. First situation is you need to go ahead and isolate absolute value. So your first step would be to subtract 7 in this problem. After subtracting 7, notice that the absolute value is still not isolated. You have -2. -2 is multiplying into absolute value. So we need to get rid of that. And in order to do that, we would divide both sides by -2. Now keep in mind this is an inequality. When you divide both sides by -2, your inequality is going to switch or flip. So we need to flip that inequality sign. We are now down to our final part of the inequality. Your absolute value is isolated. So when it's isolated, now you break it up into the positive, negative, the 2 cases. So I would have x plus 5 is greater than or equal to 4. There's our positive one. And then we have the negative, where we put the negative, set of parentheses, x plus 5 is greater than or equal to 4. Solve x for both of these problems. On the positive, I'd subtract 5 from both sides, giving me x is greater than or equal to negative 1. The next case, I'm going to go ahead and get rid of that negative, so I'll divide by negative 1. Inequality would flip when I divide by the negative 1. I have x plus 5 is less than or equal to negative 4. Get x alone, subtract 5 from both sides, and we have x is less than or equal to negative 9. So if you look at the graph, you're going to be on negative 1 and negative 9. Well, x is greater than or equal to negative 1. That is a closed circle on negative 1. The values that are greater than negative 1 would be to the right, like they have. So far it checks out. The next example, you have it on negative 9, closed circle on negative 9, and this says x is less than or equal to. Well, the values that are less than or equal to negative 9 would be to the left. So that would check out. So our answer here would be option D. This concludes 8246.